Hello, and welcome to this presentation about Content Delivery Networks, a part of the Front-End Optimization series. Content Delivery Networks, called CDNs for short, speed up downloads by keeping copies of the data closer to your users. Even though the internet is virtual, distance still matters. Bits travel at a certain speed, and the greater the distance they travel, the longer it takes them to get there. These are physics laws in action, and it's true regardless of how fast your connection is. In addition, to travel a greater distance over the internet, data packets are usually routed through more machines. Each such machine may lose the packet, requiring its retransmission. Each machine may slow down the transmission, and the slowest machine in the path sets the bottom line speed. And lastly, the path the data packets go through is not the same for all packets, and is often not optimal. Let's spend a minute on network terminology, which helps when describing CDNs. Latency is the time it takes to get a bit from one side to the other, factoring in the distance, multiple hops, and suboptimal paths. Upload latency is the time to get a bit from client to server, and download latency from server to client. Since communications often deal with a dialogue between the two machines, another useful term is round-trip time, or RTT, which is the time to take a bit from the client to server and back again. RTT is the common measurements for how quickly can two machines interact. Communication channels aren't perfect, and sometimes data packets get lost in the way. The percentage of packets that got lost is called packet loss ratio, or PLR. TCP/IP, the primary internet protocol, identifies such lost packets and resends them, but these redundant submissions aren't ideal and slow down the bottom line throughput. Which gets us to the last term, effective bandwidth. Effective bandwidth is the actual rate at which a client can pass data to a server and back again, after factoring in the round-trip time and the ratio of packets that require resubmission. Armed with this terminology, let's talk about CDNs. Content Delivery Networks, also called Content Distribution Networks or CDNs, help increase the effective bandwidth and reduce the round-trip time by caching the data closer to the user. At the core of the way CDNs work is a network of edge servers scattered around the world, or at least some other large geographical area. When a client requests a file, for example cdn.blaze.io/image.gif, the name cdn.blaze.io would resolve to the IP address of the closest edge server. This means that for the same URL, a user in Sydney, Australia, will be routed to a different server than a user in New York, US. When the edge server gets the request, it returns the local copy of the file in question. Since the request and response travel a much shorter distance, the latency and packet loss ratio are lower, and the data is downloaded much faster. If the edge server doesn't have a local copy of the file, it retrieves it from a central location, usually either the CDN's central storage or the original website. Identifying the closest server to a specific client is done using a more advanced DNS server feature called geolocation, which has proven to be fairly accurate. Since CDNs cache copies of the data, they are mostly limited to serving content that remains static, at least for a little while. Most commonly, this includes web page resources such as images and CSS files, as well as larger download files. Dynamic content, such as the web pages themselves, often needs to be recreated for every request, and can therefore not be cached and cannot be accelerated by a CDN. As more data becomes dynamic, some CDNs, such as Akamai, started offering dynamic data acceleration using various techniques. The two primary ones are routing optimizations and extremely short-term cache. Routing optimization attempts to better route data across distances by using that network of edge servers. These coordinated routers use network techniques to optimize routing paths, reduce duplicate data packets, etc. Extremely short-term cache is an attempt to cache data for very short periods, such as a minute or two. This short-lived copy may be acceptable for some dynamic content, such as news, and on a high-traffic site can still prove quite useful. CDNs are useful and easy to start with, but there are quite a few pitfalls to be aware of. The main risks CDN present is tail cache. Since the edge server caches data, you must provide detailed instructions on which files can be cached and for how long. When a cacheable resource is changed, the Edge server may still hold an old copy which it will keep on serving, resulting in broken pages. CDNs offer ways to clear files from edges, but that clearing will take time to complete. The versioning optimization, described in a separate presentation in this series, helps overcome this problem. Double payment is another concern, which occurs when a resource that cannot be cached is requested through an Edge server. The Edge will fetch it for every request, making you pay bandwidth costs to both the CDN and your hosting provider. Using a separate domain for your CDN, used to serve all and only cacheable content, prevents this problem. Stale cache and double payments are but two of many issues you may have with your CDN. Each CDN has its own default configurations, bugs, and unexpected behaviors that may get in your way. Having tested several CDNs, I've encountered many unexpected behaviors or default configurations. Some examples are disabling browser caching by default, caching content for a day regardless of the origin server's cache headers, not caching pre-compressed content, or decompressing content before serving it to a user. Most of these issues can be configured away, but you need to know to do that. The solution to this problem is to test your CDN. Use the information you get from the CDN reports and response headers to verify you're getting the caching you need, and do performance measurements to verify your pages are indeed faster. If you're using an automated CDN deployment solution or outsourcing this problem, make sure these issues are addressed. To summarize, downloading data from a remote server is slow. The high round-trip time delays every request to the server, and the high packet loss ratio reduces the effective download rate. Content delivery networks help this problem by caching a copy of the data closer to the user. The cached static data travels a shorter distance and goes through less machines, resulting in a consistently faster communication channel. That's it for content delivery networks. Be sure to check out more ways to speed up your site in the front-end optimization series on the Blaze website at www.blaze.io. Thanks for listening.